Large language models are brilliant, but they lack access to your private data. Retrieval Augmented Generation, or RAG, solved this by letting models read your internal company documents before answering a user's question. When a user types a prompt, the system converts that text into a mathematical format called an embedding. This allows the AI to search through millions of internal records to find similar concepts. As you can see in this schematic, the process forms a straight line. The query goes to a vector database. The database retrieves the top text chunks that match the keywords, and the system passes those chunks to the AI to generate an answer. If you're building a system to answer simple, one-dimensional, frequently asked questions, this single-pass, straight-line architecture works perfectly. But let's ask a harder, multi-step question. Imagine asking an AI to compare a company's B2B return policy with its B2C return policy, while specifically listing all the exceptions to those rules. A linear pipeline pulls the most relevant text chunk, say a fragment of the B2B policy, but it snaps under the weight of the request. It fails to reach the separate document containing the policy exceptions, resulting in an ungrounded answer. The AI receives that incomplete context. Because the model is designed to be helpful, it confidently generates a partial answer based on what it has, or worse, it hallucinates the missing details entirely. This architecture has no way to recognize its own limitations. It executes a single search and delivers the results, never pausing to ask if it actually found the necessary facts. Standard RAG lacks structural awareness. It simply does not know what it does not know. To fix this, retrieval has to stop being a passive, fixed pipeline. We have to wrap it in an active loop, controlled by an autonomous AI agent serving as the central orchestrator. When that complex return policy question comes in, the orchestrator intercepts it. Instead of running one massive search, it rewrites the prompt and splits it into two distinct, manageable subqueries. Next, it routes those subqueries to the right places. It might send the B2B policy search to a semantic vector database and send the exceptions query directly to a structured SQL table. The agent is now actively navigating the enterprise data architecture. It abandons simple keyword matching in favor of deliberate, strategic information gathering. This introduces a pattern known as REACT, or reason and act. When the agent receives the initial batch of data from those databases, it doesn't just output a response. It pauses to evaluate the evidence against the original prompt. In this reasoning phase, the agent might realize the text it pulled explains the return policies, but the specific clause about exceptions is still missing. Instead of hallucinating, the agent takes corrective action. It backtracks, refines its search parameters based on what it just learned, and dives back into the databases to locate the missing clause. This persistent, iterative behavior mimics a human researcher digging through files, refusing to accept a dead end. Even after the agent compiles all the facts and drafts an answer, there is one final gatekeeper. We call this the sufficient context judge. This node acts strictly as a quality control inspector. It isolates every individual claim in the drafted response and cross-references them against the retrieved source documents. If the judge finds a claim that lacks explicit documentary support, the draft is rejected. The agent receives a failure signal and is forced to initiate an entirely new search cycle to find the missing evidence. This enforces a non-negotiable rule within the system architecture. If there is no verified evidence, the user receives no answer. Agentic RAG loops introduce significant operational costs that must be managed. Looking at this comparative chart, you can see the toll of this exactness. Because an agent might run 3 to 5 separate retrieval calls per request, the token usage, system latency, and overall cost soar compared to a standard setup. If you're building a customer support bot to handle thousands of simple, single-document lookups an hour, that added cost and latency will work against you. Standard RAG remains the optimal choice for that volume. Enterprise architecture choice is a deliberate, calculated trade-off. Engineers must weigh the need for speed against the absolute requirement for verifiable accuracy. But in fields where an incorrect answer carries immense liability, like medicine, corporate law, and enterprise finance, rigorous verification is the only path forward. These loops force the AI to act as a researcher, verifying every claim against grounded evidence before it summarizes an answer. Autonomous, persistent reasoning loops provide the foundation for the next generation of enterprise AI.